Hey, this is section 5-1. We're talking about standard normal distributions. So 5.2, we talked about just regular normal distributions. And if you remember this, these points about normal distribution, they are going to apply today as well. So again, just in the way of review, on a normal distribution, the middle of that distribution is the mean, and the mean, median, and mode are all equal. So that means that it's symmetric and all of those measures of center are in the center. No matter how spread out the data is or how squeezed together it is, the mean, median, and mode are always equal. It's a bell-shaped curve. These points right here and right here are one standard deviation away, and they are called the points of inflection. And we consider any data points that are more than 2 standard deviations away. So that would be in this tail or this tail. We consider those values unusual. So as you're measuring, if you measure up more than 2 standard deviations or back more than 2 standard deviations, that's an unusual data point. The total area under the curve is 1, because remember, we're measuring percentages. What's the percentage? What's the chance that I randomly draw a person and they fall in this area? And so all of our answers are percents. So the total percentages all add up to 100%. So that's what we're talking about today. Again, normal distribution. Here's the only change with 5.1. In 5.2, we would take a situation like, let me draw this way. Let me draw a number line, big number line, because we're going to use the whole thing. Okay. And say we've got 0 down here somewhere. And up here, let's say we're taking a standardized test. And let's say, for example, that the mean is 1320 and the standard deviation is 298. So I've got 1320 here. These test scores are normally distributed. So we've got some kind of a normal distribution here, and pretend like that's all a great picture and symmetric and everything. Okay. My middle's 1320. And then I've got this standard deviation counting out, to, what is it? 298 on either side of it. Now I can ask you questions about this normal distribution, but what a standard normal, so let's label this is a normal distribution. But what we're doing today is we're going to say, hey, I can take these values and I can slide them down the scale and I can create what's called a standard normal distribution. So that is like this. It's the same shape. Okay, it's the same width, it's the same height, all that stuff is the same. It's just gotten shifted down the number line, and 0 is now the center and 0 is the mean. Okay, so this is called a standard normal distribution. So they work the same way. Your calculator works the same way. You really are going to do the problems all the same way. It's just that now, instead of our mean being 1320, it's now going to be 0. And instead of our standard deviation being 298, like in this, our standard deviation on the standard normal curve is always 1. And so it just makes things a little bit easier. The numbers are always consistent and that sort of thing. Now, what goes with this is this Z-score formula, which we've already talked about. You've already used this, so let me remind you of that. A Z-score is going to be the value that you're looking at. That's your X value, whatever score you're interested in measuring. You're going to subtract the mean and you're going to divide by the standard deviation. That's that formula for you again. And that's the formula that converts us from a normal distribution to a standard normal distribution. So if I take all of my data points and I apply that formula to them, they will slide down and my mean will become 0 and my standard deviation will become 1. Okay. So some of your homework problems are going to just very simply ask you for the Z-score of a data point. So for example, I could say, find the Z-score of a test of, let's say, 1358. Okay, So I'm going to take that value and I'm going to plug it into this Z-score formula. Z is going to be 1358 minus the mean. My mean is going to be 1320. And I'm going to divide it by 298. Now, remember on your calculators, if you're doing this, typing this whole thing in together, you need to put parentheses around the top. So I'm going to go parentheses 1358 minus 1320, end my parentheses, and then say divided by 298. And I get a Z-score of 0.128. All right, well, what is this? That number represents how many standard deviations away from the mean this score is. So I look at that 0.128, that means that Z-score is that value, that test score is very close to the mean. It's less than 1 standard deviation away. And what's nice is that it's really easy to tell by the Z-score if it's an unusual data point or not. If you get a Z-score of 2 or bigger or -2 or smaller, then it's unusual. If it's anything between -2 and 2, then it's a usual, it's a typical score. So I would say, like on my picture here, if I wanted to draw a picture of where this is, the test score is 1358. That's about right here. And if I use my Z-score to graph it over here, that's 0.128. That's about here. Notice that relatively it's in the same place relative to the mean. It's just been slid down. It's still just slightly to the right of the mean on both graphs. And that's the idea. So it's an easier way to look at data points. That's how some of your homework problems will look. The other problems will look like this. It'll say on a standard normal distribution, find the probability that the Z-score, that's what this P means, remember from chapter 3, the probability that our Z-score is between -1.47 and 0.7. Now, let me draw a picture of this and then I'll run through it on the calculator with you first, so you have an idea of what's going on. So this is saying I'm a standard normal curve. So what that tells me is that my mean is 0. And my standard deviation is 1. That's what this tells me. So don't be thrown by the fact that you're now in 5.2, I gave you a mean and standard deviation, and now I'm not giving you that. It's because you're supposed to know, because it's a standard normal distribution, your mean is 0, your standard deviation is 1. Okay, so that's important information. And then I want to know, what's the probability, what's the area under the graph, what's the probability that somebody is between -1.7 and 0.7? Where is that? -1.47. Let me mark out 2 standard deviations here. So -1.47 is like roughly right here, and 0.7 is just before 1. So it's asking, what's this area right here? What's the probability that somebody falls in that range if they're randomly selected? So you do this on your calculator the same way you did chapter 2. You're going to go up, if you're on a TI, you're going to go second function, distribution right there. You'll get a square that says distribution, and your first option is normal PDF. Your second option is normal CDF, and this is the one that you want. Okay, when you hit select on that, you're getting this square coming up your home screen, and it's saying what's your lower, what's your upper, what's your mean, what's your standard deviation, and then paste. So my lower on this problem is going to be -1.47. That's your lower is left, remember? So -1.47. My upper is my right-hand limit, 0.7. And my mean is 0. My standard deviation is 1. So if I enter those, -1.47, 0.7, 0, and 1, I get a value of 0.687. So there's a 68 68.7% chance that somebody is found in that range. Okay, now real quick on ClassCalc, just a quick reminder. You're going to go here, make sure you're in graphing mode up in the upper right-hand corner. That gives you access to all your statistics stuff. I'm going to hit statistics right here. And I'm going to distributions and plots. I'm going normal distribution, and it prompts me right here for what's your mean and standard deviation. So I'm going 0 and 1. And remember, if you hit your magnifying glass right here, it'll pop that picture up and put it in scale. If you don't see a picture, hit the magnifying glass, and you should. And then you're going to go over here to CDF. So if I type on that, it offers me an inequality. Now, right now, the whole thing's colored because it says negative infinity to infinity. That's the area under the whole curve. Guess what it is? It's 100%. This is 100% of the data points. Now we want to limit those. The left is going to be negative 1.47. And the right is going to be 0.7. And if you look here, that picture should just look like what you drew on your paper, and it does. That's helpful. And here's your percentage, 68.7% or 0.687 is your answer. So that's how you do your distribution problems. Between that and your Z-score, that's all you're going to need to navigate on this homework. I'll talk to you soon.